Morning, students. Um, all right, guys. I think let's give it a few minutes. Just wait for others to join. Um, and I'm also waiting on Mr. Beaumont to come in and give me the presenter rights as well. So please, let's just be patient for a few minutes. We're going to start soon. Okay, good morning, guys. Let me take this time and welcome you to our second meeting or the second workshop. Okay, can you guys indicate with the thumbs up? Audible enough? You guys hear me?
Okay. Is the presentation visible to your side? You guys see it? Can somebody unmute and just let me know if the presentation is visible. Just unmute for a second. Uh, okay. Still not visible. Let me unshare and reshare again. Okay. Is it what about now? Is it visible? You guys see it? Is it up? Can you guys see it? Still can't see. Um. So yeah. All right. Okay, can you guys please indicate again if you can see it? Is it visible? All right, brilliant. I hope everybody can see it. Um, okay. If it disappears again, please feel free to just unmute your mic and say, let me know so that I will stop and reshare again. Okay. All right. Today we're looking at numbers, rounding of numbers, and we'll look at basic operations on numbers as well. Sorry. So just a few things that you should be able to learn during this lesson. To be able to identify the different kinds of numbers. You can draw a number line, round off numbers. You'll be able to perform basic operations on numbers. Okay, let's jump into it. What are numbers? So we use numbers to describe and measure quantities. So numbers will answer the questions that say how much, how big, how many. So we use numbers to answer those kind of questions. So a number is an abstract entity, an idea that is used to express a quantity. So various symbols can be used to represent the same number. For example, if we take 9, 9 can also be written as the number 9. And you can also represent it as 5 plus 4. It can be written as the word 9. Then you can also use the Roman figure IX to represent the same number 9. So the most fundamental system of numbers is the natural numbers. We use this system to count things, starting with the number 1. So the natural numbers will start from 1. So we can write it as a set, as a grouping, or collection of similar things. So a set will be represented by curly brackets. So those brackets are often used to indicate a set. The set of natural numbers is given as that set. So we have the curly brackets that enclosing 1, 2, 3, 4, 5, and the dots. The dots at the end indicate that the set continues indefinitely. So the set continues up to infinity. So the elements of the set are 1, 2, 3, 4, 5, and so on. So those numbers inside the curly brackets are known as the elements of the set. The natural numbers can be used for counting. So we use them for counting. So there are two books on the table, as an example. They are also used for ordering. So we arrange things in sequence with the fourth or the largest apple. So those are just the two examples where we find the use of numbers. So natural numbers are also called positive integers. They're also called positive integers. So to indicate the absence of certain things, such as when your team fails to score, or the number 0 was added. So it indicates nothing. These are the set of counting numbers. So the set of counting numbers now starts from 0. 0, 1, 2, 3, 4, 5, up to infinity. So counting numbers are also called non-negative integers. So they're called non-negative integers. Situations may arise where positive numbers alone are not sufficient. For example, we can subtract a larger number from a smaller number. But the negative numbers are usually represented by a minus sign in front of them. The set of negative numbers now will start from -1, -2, -3, -4, -5, up to negative infinity. So these are the numbers that are less than 0. So when working with negative numbers, it is important to distinguish between the sign of an operation, the addition or subtraction, the sign of a number. Negative numbers are used to describe values that are below zero, such as temperature and debt. So these numbers also provide a convenient way of indicating opposite direction with a minimum of ways. For example, inside steps inside a building, we will see shortly building. The following examples illustrate the positive and negative integers. Let us look at something we are familiar with, that is steps inside a building. We indicate ground level where there is no step as 0. So let me show you the building. This is an example. So the ground level where 0 is that is the origin. And then as you move up a step, the signs in front of the number now indicates the direction. So you're going up one step, that means you go to positive 1. 2 steps, positive 2, positive 3. As you move to the opposite direction, you get negative 1, negative 2 in the second step, and then negative 3, and so on. So the plus sign does not indicate the operation of addition. So it is a sign of direction, like I mentioned. In this case, meaning above ground level. So in the basement, the steps are numbered negative 1 to negative 3, so indicating below ground level. So combining the negative integers and non-negative integers, or 0 plus positive integers, yields a set of integers. Those numbers that are below 0, 0, and then negative integers or positive integers. So those numbers that are above 0. So this is called the set of integers. Okay. So the number line is one way to represent a set of natural numbers graphically, or set of numbers graphically. So to illustrate the construction of a number line, we place the elements of the integer set in one-on-one correspondence with points on the line. So what you do, the first thing is just draw a straight line horizontally and mark a point near the middle as 0. So this is the starting point or the origin. So we call this point the origin. Since the integers are equally spaced, we select points around 0 with equal distance between them. So this distance between any 2 points is called the scale. A familiar scale being the scale on a thermometer, if you say a thermometer. So certain conversions are usually followed when using a number line. Positive integers are associated with points to the right of 0. So then to the right of 0, those are positives, and then to the left of 0, it's the negative integers. The arrows at the end obviously indicate that the set continues indefinitely. So thus far, we have not mentioned any numbers other than integers. So the number line also gives us a picture of the relationship between integers and other numbers. So the integers are marked on the line, but each point in between the integer markings also represents a number. Examples are the points representing the numbers half or 1.2, which is located between 0 and 1. So at the center of 0 and 1, you get the number 0.5 or 1 over 2. And you also have negative 2.5, which is located halfway between negative 2 and negative 3 on the line. So we have other numbers as well that we haven't mentioned, so which are, for example, half and negative 2.5. So all these points on the number line, that is the solid line,
represent the set of real numbers. So these are the set of real numbers. Not that integers are real numbers, they are special real numbers. Okay, if I were to ask you what kind of a number is -1 and what kind of a number is positive 3.3 over 4. So obviously you would say -1 is a negative integer. So this is the number that is below 0. So it's a negative integer, or it's a negative real number. So 3 over 4 is a positive real number as well. So it is a real number that is positive. Okay, let's look at rounding numbers. Rounding is the process of reducing the number of digits in a number while trying to keep the value similar. Rounded numbers are less accurate, but they are easier to use. We round them to make things easier for us. So in this course, we will be using the common method to do rounding. The rule for applying this method is as follows. So you have your number that needs to be rounded. So the first thing you decide which is the last digit that you will keep. This will probably be given in the question, maybe round to this much decimals. So you decide which is the last digit that you will keep. The second thing is to increase this digit by 1 if the next digit to the right is 5 or more. If the next digit to the right is 5 or more, you increase this digit, the one that you've decided that you're going to keep, and then you discard the rest. So the last thing, you leave this digit the same if the next digit to the right is less than 5, and discard the rest. You leave this digit the same if the next digit to the right is less than 5. Okay, an example is given that we should round 4.36925 to 3 decimal places. So you want to keep 3 digits, so the 9 will be the last digit. So we have 4.36923. So we're asked to round to 3 decimals. So the 9 is the third number. So this is the third decimal, so we want to keep 9. So the next digit to the right is 2. So to the right, that's the one that comes immediately after 9. So that number is 2. So the rule says if this number that comes after the one we decided to keep, if it's less than 5, what do? We leave the number that we've decided to keep, we leave it as it is, and then we just discard the rest. So it's less than 5, so we drop 2, 3. The 2, 3 part will be, we just drop it, and then we get 4.369. Number 2, round 4.36923 to 2 decimal places. So solution, you want to keep 2 digits. So the 6 will be the last digit. So we have 3, 6. So 6 is the last digit we want to keep. So the next digit to the right of 6 is 9, which is more than 5. So the rule says we should add 1 to the 6 and drop 9 to 3 part to get 4.37. We take 1 and then we increase the 6 by 1, so we get 4.37. All right, another example, round 4.36923 to an integer. That means we're just rounding it to the whole number. You want to keep only integers. So the 4 is the last digit. So the next digit is 3, which is less than 5. So we drop 369 to 3 part to get 4. Okay, around 5.6521 to an integer, and round 2.468 to an integer. Can you guys round those two for me? Just write them on the chart when you're done. Round those to an integer. So we just want to round them to the whole number. Please try those and then write them on the chat section for me. The number is broken correctly. Well done. Well done. So we're rounding to an integer. So it's 5.6. So we keep 5, obviously. And then, because we're looking at the next number that comes, so the next number is 6, which is above 5. So we increase the integer by 1. So to get 6. Well done, Manam. Okay, the second one, which is round 2.4688 to an integer. So we keep 2, obviously, and then we look at the number that comes after that. So we see that it's 4. 4 is less than 5, so that means everything else that comes after 2 will be discarded. So we leave 2 as it is. So the correct answer is 2. Brilliant. Great. Well done, guys. Okay, let's proceed. So that's 6 and 2. Okay, before rounding a number, you need to think carefully. Keep the following in mind. If an interest rate is 16.25, then you should not round it to 16. There is a big difference if you calculate interest on a loan using 16%, and instead of 16.25. So there's always a big difference. So you should be careful not to round when it comes to interest rates. So however, what does it mean if you calculate the price of an article as to 27 rand 5394, 27.5394. When working with money, it makes more sense if we round to 2 digits. So we would have 27.54. So do not round to integers unless it is obvious or asked for. And do not round in the middle of a problem. Use all the digits and only round when you get to the final answer. All right, an exercise for you guys. Round the following numbers to 3 decimal digits. And then you are asked to round the numbers to 2 decimal digits as well, round the numbers to integers. So that's for you guys. Can you can you please work them out and then just write them on the chat section as well. A 4.57849 round to 3 decimal places, and then you have 0.39887 round that to 3 decimal places, and then you also have 10.0004. You're asked to round to 3 decimal digits as well. Work them out and just write them in the chat section for me. Okay. Yes, guys, well done. Well done. Thank you all for working the problems out. That was brilliant. You guys did very well. You did very well. Thank you. Can I ask, there's a person who's got the mic on. Can I please ask you to mute the mic? Okay, thank you. Well done, guys. Okay, there's a confirmation of the answers. So 4.57849 becomes 4.578, and then 0.39887 becomes 0.399, and 10,004 becomes 10,000. Okay, to two decimal places, 7,9747. 7,9747 becomes 7,97. 10,495 becomes 10,50, and then 8,9998 becomes 9,00. Carry around the following to the integers. 12,034 becomes 12. 9,8745 becomes 10. 0,0342 becomes 0. Well done, guys. I said that you got those correct. All right, let's shift our attention to the basic operations of numbers. Okay, so there's 4 basic operations on numbers. So we have addition, we have subtraction, we have multiplication and division. Okay, so when numbers are added, the answer is called the sum of the total of the numbers. So the sum or the total of the numbers. The sum of 2 real numbers is unique. What does that mean? It means that it doesn't matter which number is placed first and which second. You will always get the same result. So for example, if we have 6 plus 2, this will be the same as saying 2 plus 6. Both of those will give you 8. So the sum of 3 numbers also does not depend on which 2 are added first. The result is unique. So let's have a look at it. You guys feel free to take a calculator and confirm this as we go. You can use your calculator to try and confirm for yourself. So 2 plus the sum of 5 and 4 in brackets is the same as adding 2 and 5, getting an answer, and then add 4 afterwards. So both of those will give you 11. So try these 2 examples on a calculator and see if you come to the same conclusion. Okay. When numbers are subtracted, the result is called the difference of the 2 numbers. Let us investigate if the difference of 2 real numbers is unique. Again, take a look at numbers 6 and 2. 6 minus 2 is equal to 4, and 2 minus 6 is equal to negative 4. We see that 6 minus 2 is not equal to 2. Is not equal to 2 minus 6. So the sign given there is read as does not equal, or it's not equal. So changing the order when subtracting leads to the negative of the initial result. Therefore, the difference is not unique. That means reversing the order will give you different result. This result means that we need to make sure that the order is correct before we do any subtraction. Okay, exercise. Which of the following statements are true? Show your calculations. So it's easy, this one. You can even use your calculator. Just use your calculator to prove that the right-hand side is equal to the left-hand side, or the left-hand side is equal to the right-hand side. And then tell me if A is true and B is true or false. Okay. Okay. Um, Looks like we've established that those statements are true. Both of them are true. A and B are true. Well done, guys. So 7 plus, we deal with that bracket first. So we get 3 plus 2 to get 5. So 7 plus 5 is 12. That is the left-hand side. And then the right-hand side, we deal with the bracket first. 7 plus 3, which gives us 10, plus 2, it's 12. So 12 is equal to 12. Left-hand side is equal to the right-hand side. So that statement is true. Let's look at the second one. B6 plus -5 plus 3. So -5 plus 3 gives us -2. So 6 minus 2 is equal to 4. Okay, that is the left-hand side. So let's look at the right-hand side. 6 plus -6, 6 minus 5, which is 1, plus 3, which gives us 4. So 4 is equal to 4. The left-hand side is equal to the right-hand side. So that statement is also true. Well done, guys. You got those two correct. Okay, let's look at the second one. That's number 2. We're asked to write the following as an equation. Write these as equations. Okay. Subtract 5 from 8 to get a difference of 3. Subtract 5 from 8 to get a difference of 3. So you're writing it as an equation now. Writing it as an equation. So we're subtracting 5 from 8 to get a difference of 3. And then you subtract -5 from -8 to get a difference of -3. Can you attempt to write those two as equations? Okay. Okay. Subtract 5 from 8 to get a difference of 3. So we have 8 minus 5 is equal to 3. 8 minus 5 is equal to 3. And then subtract negative 5 from negative 8 to get a difference of negative 3. So we have negative 8 minus 5 is equal to negative 3. So well done, guys. You got this correct as well. So 8 minus 5 is equal to 3. Negative 8 minus negative 5 is equal to negative 3. Brilliant, guys. Okay, let's continue. So consider the following problem involving multiple operations of addition and subtraction. So an example is given where a train leaves its terminus with 19 passengers on board. At the first station, 4 passengers get off and 9 get on. get on. So at the second station, 15 get off and 1 get on. How many passengers remain on the train? So obviously the most logic way of answering this is saying 19 minus 4 is equal to 15. And then from 15, you add 9. 15 plus 9 is equal to 24. Then 24 minus 15 is equal to 9. And then adding the 1, 9 plus 1 is equal to 10 passengers remaining. So which is the correct answer. So if you're faced with this problem, 19 minus 4 plus 9 minus 15 plus 1, you should simplify it in the same way. That is from the left to right. That means 19 minus 4 plus 9 minus 15 plus 1 is equal to 10. You can write the whole statement in one line. That is as an expression, in one expression. 19 minus 4 plus 19 minus 15 plus 1. And then perform your operations from left to right. That means you will start with the subtraction of 4 from 19. And then that you get that answer. And then add 9. From that answer, you subtract 15. And then lastly, from your answer, you add 1. It will give you 10. So when an expression contains only the two operations of addition and subtraction without any brackets, the rule is to perform them from left to right. That is, you apply the left to right rule. You apply it left to right, you perform them from left to right. Okay, let's look at multiplication and division. So when two numbers are multiplied, the answer is called the product of the two numbers. The numbers we are multiplying are called factors. So the numbers that are multiplied are called factors. Again, the product of two real numbers is unique. That is, it does not matter which number is placed first and which second. The result is always the same. For example, and also feel free to use a calculator to confirm these as well. As we move, 6 multiplied by 2 is the same as 2 multiplied by 6. So these will give you 12. So the product of three numbers also does not depend on which two are multiplied first.
All right. iPhone with the London.
Someone has the mic on. Can I please ask you to mute your mic? Thank you. Okay. So we said, okay, the product is also unique. So the multiplication of two real numbers is unique as well. That means it doesn't matter which number is placed first. So we have 6 multiplied by 2 is the same as 2 multiplied by 6. So both of these gives us 12. So also the product of three numbers also does not depend on which two are multiplied first. The result is unique. For example, if we have 2 multiplied by the product of 5 and 4, which is 5 multiplied by 4, is the same as multiplying 2 and 5 together first, and then multiply that product by 4. Both of these will give you 40. You can confirm this by using a calculator as well. Okay, let's proceed. When multiplying with plus and minus signs, the rule is as follows. If you multiply two numbers with the same signs, the answer is a positive. So if you multiply with the same signs, so the answer is positive. That means a positive multiplied by a positive is equal to a positive, and a negative multiplied by a negative gives us a positive. So if we multiply two numbers with different signs, the answer is a negative number. That is, a positive multiplied by a negative gives us a negative, and a negative multiplied by a positive gives us a negative. Note that we usually do not write the positive sign, that is the plus. A number without a sign indicates a positive number. So you just have to know that there's a positive sign if the number is without a sign. So let's have a look at the examples that are given. We have a negative 2 multiplied by a positive 3. So we have a negative multiplying on the positive, so the answer is negative. And then 2 times 3 is 6. So we have the second one is negative 2 multiplied by negative 3. So two similar signs, negative and negative. We said they will give us a positive. So we have 2 times 3, which gives us 6. Okay. When one number is divided by another number, the answer is called the quotient. Now we're looking at the division. So the specific terminology we use in division is we have the dividend divided by the divisor gives us an answer which is called the quotient. We have a dividend divided by a divisor is equal to the quotient. So if we look at 6 divided by 2 is equal to 3. 3 is the dividend, that is the number that is being divided, and then 2 is the divisor, which is the number that is dividing, and then 3 is the answer, which is called the quotient. So let us investigate if the quotient of two real numbers is also unique. I can take the two numbers 6 and 2. So 6 divided by 2 is equal to 3. And if you reverse the order, that means 2 divided by 6 it gives us 1 over 3. So we see that these two are not equal. So these two are not equal. So changing the order when dividing leads to the inverse of the initial result. So it gives us the inverse of the initial result. That is 1 over 3 instead of 3. And therefore the quotient is not unique. When dividing with plus and minus signs, the rule is as follows. If we divide two numbers with the same signs, the answer is a positive number. That is, a positive divided by a positive will give us a positive answer, and a negative or a negative divided by a negative, we get a positive answer. So if we divide two numbers with different signs, the answer is a negative number. That is, if we have a positive number being divided by a negative number, we'll get a negative number. And if we have a negative number being divided by a positive number, we'll get a negative number. So an example is 12 divided by positive 12 divided by a negative 3. It will give us a negative 4. We have a positive being divided by a negative number. So we get a negative number, so negative 4. And the second one, we have a negative 12 divided by a negative 3. Negative and a negative gives us a positive. So it's going to be positive 4. So when adding long rows of numbers, it does not matter which numbers we add first and which last. Similarly, this applies to multiplication as well. But when it comes to subtraction and division, we have to tread very carefully, as the following examples show. 10 minus 5 minus 2 is not equal to 10 minus 5 minus 2. So, and 8 divided by 2 divided by 8 divided by 4 and divided by 2 is not the same as 8 divided by 4 divided by 2. This means that an expression like 8 divided by 4 and then divided by 2 is highly ambiguous because the result depends on the order in which we perform the operation or the division. So your calculator, which is a sharp EL738 FB, interprets 8 divided by 4 divided by 2 as 8 divided by 4 divided by 2, which is equal to 2 divided by 2, which is equal to 1, since it works from left to right. So which is the correct order. We have a division and a division, so we'll operate from left to right. So when an expression contains only two operations of multiplication and division without any brackets, the rule is to perform the operation from left to right. Therefore, 8 divided by 2 multiplied by 4 is equal to 16. So which is 8 divided by 2, which is 4, multiplied by 4, which is equal to 16. So you can enforce a specific order by using brackets. For example, 8 divided by 2 multiplied by 4. So that means now we're going to start at the bracket. We go start with the multiplication instead of moving from left to right, because we have to deal with the brackets first. So we'll have 8 divided by 2 multiplied by 4, which is 8. So 8 divided by 8, which is equal to 1. So we can conclude that although we can change the order of numbers for addition and multiplication, we cannot do the same for subtraction and division. Now, let's have a look at the exercise. Which of the following statements are true? Which of the following statements are true? Then show your calculations. Okay. Now, to prove that the left-hand side is the same as the right-hand side. And then you can give me the answer. What do you get for the left-hand side? What do you get for the right-hand side? Are these statements true? So they will only be true if the left-hand side is the same as the right-hand side. So I also want you to do the number 2, write the following as an equation. I'm going to give you the next 5 minutes. Okay, well done, guys. Okay, the first statement is true, and the second one is false. And I'm glad that you guys have showed and proved that those statements are true and false, respectively. Okay, let's just go through it together. So we have -7 multiplied by the product of 2 and -3. So obviously we're going to start at the bracket. Inside the bracket there's 2 and -3. 2 times -3 is -6. So -7 multiplied by -6. So it's a negative and a negative, so it's positive. 7 times 6 is 42. So we have positive 42 on the left hand side. Let's go to the right. We have -7 times 2 multiplied by -3. We'll start at the bracket as well. So we have -7 multiplied by +2. So -7 times +2, it's -14. -14 multiplied by -3, negative and a negative, positive, and then 14 times 3 gives us 42. So the first statement is indeed true. Brilliant, guys. Okay, let's see the second one. 12 divided by open bracket -4 divided by 2 close bracket is equal to open bracket 12 divided by -4 close bracket divided by 2. Okay, start at the left hand side. We started the bracket as well. Inside the bracket there's -4 divided by 2. So we have a negative divided by a positive. So the answer is obviously going to be a negative. So we have -4 divided by +2, so which gives us -2. So 12 divided by -2 is -6. We have +12 divided by -2, so we get -6. That is the left hand side. The right hand side, 12 divided by -4, which gives us -3. And then if you divide -3 by +2, you get -3/2, or -1,5. So the left hand side is not equal to the right hand side. So that means that statement is false. You got that one correct, guys. Again, well done. So write the following as an equation. Divide 8 by -2 to get a quotient of -4. So just write 8 divided by -2 is equal to -4. You wrote that. So 8 divided by -2 is equal to -4. Okay, let's continue. Okay, consider the following problem involving multiple operations of multiplication and addition. It's actually multiplication and division. There's no addition. So a restaurant catering for a large party sits 6 people to a table. Each table requires 2 dishes of vegetables. How many dishes of vegetables are required for a party of 60? So most people would answer this by saying 60 divided by 6, which is equal to 10 tables, and 10 multiplied by 2 is equal to 20 dishes. And this is correct. So if this problem is set as 60 divided by 6 multiplied by 2, then the left to the right rule must be used. So if you did not use this rule, you might get 60 divided by 6 times 2, which is equal to 60 divided by 12. which is equal to 5, which is incorrect. That means if you started the multiplication, you would get an incorrect answer. So you should use the left to right rule. That means start at the division and then go to the multiplication. Okay, I think there's an exercise again. There's an exercise again. It involves multiple operations. Can you guys quickly work through that exercise? And then share your answers as well on the chat section. All right, guys, well done. That's brilliant. Thank you all for working. Okay, see someone says they can't see the screen. Let me try and unshare and reshare again. Let me know if it's visible again. Guys, please indicate with a thumbs up. Is the document visible on the side? Okay. All right, there goes your answers. There goes your answers. I see that you guys you got them correct, pretty much all of you. All right, that's brilliant. Well done, guys. Well done. So, in summary, if only two operations appear in an expression or equation, we operate from left to right. So, for instance, in the first case, we have only subtraction and addition. So we operate from left to right. That means we first deal with the subtraction and then we go on to the addition. Similar to the second one, we have addition and subtraction. So we add 6 to 16 or 16 to a 6, and then we subtract 7 from the answer. And as well, number 3, left to right, that means first add 3, and then from that answer we subtract 30, from the answer you subtract 4, and then you add 4. And then number 4 is only multiplication and division. So obviously we operate from left to right. We start by multiplication and then we go to division. Number 5 as well, division and multiplication. So we first deal with the division and then go to the multiplication. And the sixth one, we deal with division and then multiplication. We multiply the answer and then we divide whatever we get. I think that's the end of what we planned or I plan to do today. I'm glad that you guys participated. I hope you have learned a lot today. So what I want to do now is just go back to what we were doing because I see that we still have some minutes. I want to go back to what we were doing on Thursday. Thursday we looked at simplification of expressions, simplification of algebraic expressions. So I want to go back there. I'm going to stop sharing this one. The slides are gonna be made available to you guys. I'm gonna send them to Mr. Beaumont. He's the one who's going to distribute them to you at a later stage. Let me share this one with you. Just bear with me a minute. Okay, about the recording, I don't know how is it going to be sent to you guys. I'm not sure how it's going to be made available to you, but I'll ask for you from Mr. Beaumont if how is it going to be made available to you. Okay, I'm gonna ask for you. All right, let me share. Okay, guys. Just give me a thumbs up if the document is up. Is it? That's brilliant. Okay, thanks. Thanks. I just want to. Okay, we talked about simplification of algebraic expressions, and this is because I just want to share. I want to share an old question paper with you. I'm sure you remember the steps that we talked about. We said the order of operations rules are you operate inside the brackets first, and then you deal with the exponents from left to right, and then you deal with the multiplication and division from left to right, and then lastly you deal with addition and subtraction from left to right. So if all these appear in the same expression, so this is the order. You will deal with operations inside the parentheses or brackets first, and then you go deal with the exponents from left to right, and then you go deal with multiplication and division from left to right, and then addition and subtraction from left to right. So the order of operations is abbreviated as PEMDAS. This order must be followed when simplifying any expression, whether it's numerical or algebraic. So this one we just showed, we just proved. Okay, now let me skip to here. Expanding expressions. What if it is an algebraic expressions? For an algebraic expression, the distributive law applies. The distributive properties may be described as follows. We have A multiplying B and C, the sum of B and C. So that means we're gonna multiply A and B first. That is to break that bracket to get AB, plus we multiply A and C to get AC, sorry. And then the second one is A multiplying on B minus C. So we multiply A and B first to get AB, and then minus A and C first at second, so sorry, to get AC. So where A, B, and C can be any numbers. So we use this property when simplifying algebraic expressions. For example, to simplify 5 multiplying on y minus 6. We follow these steps. We'll first multiply 5 and y to get 5y, and then we'll multiply 5 and 6 to get 30. And that means we're going to get 5y minus 30. 5 times y minus 5 times 6 is equal to 5y minus 30. Okay, let me run. Okay, the distributive properties. There they go. Let me run. I think we talked about this. I'm gonna stop sharing this now and then share the question paper with you. I was just trying to remind you. Okay, is the question paper up, guys? Can you see it? Can you guys see it? Okay, not yet. All right. Stop sharing. Let me share again. Is it up? Okay. Okay, sweet. Okay. I want you guys to try and simplify question 1 for me. Simplify question 1. We have 6a to the power 2 minus 9ab plus 2b squared minus 3ba minus 3b squared. I want you to simplify. You've got options there, option 1, option 2, option 3, option 4. So what is the simplified version? The simplified version of that expression in question 1. I think in the few minutes that we have left, we can do that one. We have 6a squared minus 9ab plus 2b squared minus 3 multiplied by ba minus b squared. Remember the arrangement that I talked about of variables? in an expression. So AB is the same as BA. So you rearrange AB or BA as AB. Arrange BA as AB. So AB and BA are the same. Okay, maybe let me the question says simplify. I don't know if you can see it clearly now. Simplify the following expression. It is 6a squared. It is 6a squared minus 9ab plus 2b squared minus 3 open bracket, that is 3 multiplying on the bracket of ba minus b squared, close bracket. It's 6a squared minus 9ab plus 2b squared minus 3 open bracket ba minus b squared, close bracket. So the options that you're given are 6a squared minus 12ab minus b squared. The second one is 6a squared minus 6ab minus b squared. The third one is 6a squared minus 12a squared b squared plus 5b squared, 5b to the power 4. And then the last one is 6a squared minus 12ab plus 5b squared. Okay, 6a squared minus 9ab plus 2b squared minus 3 into ba minus b squared. So remember, the first thing, you start at the bracket, break the bracket down. But inside the bracket, you see that there's a rearrangement of variables that has to be done there. You have BA. So remember, we talked about rearranging them alphabetically. So BA is gonna be AB. So that is AB. And then you multiply everything that is on the bracket by that 3 that is outside the bracket. Let me know, what do you get? Okay. I see that you guys are getting similar answers. So you're getting option 4. Okay, so 6a squared minus 9ab plus 2b squared minus 3 multiplied by ab minus b squared. Okay, so the first term is going to be 6a squared, obviously. So 6a squared has nothing that we can group with in the whole expression. So we will have 6a squared minus, but we do have an ab, that is negative 9ab, and then we have negative 3ab. because if you multiply on the bracket by 3, we will get negative 3ab, and then multiplied by b squared, and then we get plus 3b squared. The bracket becomes negative 3ab plus 3b squared. And then so now we can group. We have 6a squared minus 9ab minus 3ab. So that is minus 9ab minus 3ab will give you negative 12ab. So we get negative 12ab. So so the second term is negative 12ab. And then the third term, we see that we can group 2b squared and positive 3b squared. 2b squared and positive 3b squared. So 2b squared plus 3b squared gives us 5b squared. So you guys are correct in saying the correct one is option 4. So 6a squared minus 12ab plus 5b squared. Okay, let me share another one. We will continue with this question paper maybe next week when we meet again. Let me share another question with you from another year. Is it visible on the side, guys? Please indicate with a thumbs up. Again. Yay, brilliant. Okay. I want you to do that number 4 quickly. So simplify the following expression as far as possible. We have a and the bracket into bracket 2a squared minus a minus 4 close bracket minus 2a open bracket a plus 3 close bracket minus 1. So you're given the options as well. So A multiplies on the first bracket, you multiply everything in that bracket by A. A multiplied by 2A squared minus A multiplied by A minus A multiplied by 4, and then minus 2A multiplied by A minus 2A multiplied by 3, and then minus 1, and then simplify that expression. Okay, yes, well done, guys. Well done to those who got it. So the correct one is of 2a cubed, or 2a to the power 3 minus 3a squared minus 10a minus 1. So that is the correct option. Well done to you guys. Okay, I think we should, because we are supposed to finish at 11:30. So I see it has gone way past 11:30, and I want to apologize to you for taking a little bit of your time. I'll try to stick to time next time. So let me take this time and thank you all for attending today, and thank you all again for participating. So remember that you will be perfect if you practice. So mathematics is all about that. You have to practice to get perfect. I'll try and get the questions for you after we do everything, and just give you guys a feel of how these questions are asked. So let's meet again. I think it's next Thursday. Thank you again all for making it. Have a beautiful day further. All right, thanks guys. Bye.